So we have pure substances, right? And we learned earlier that we have two types, right? We have an element, the most simple, right? And then we have compounds, right? And that's where we have two or more elements, okay? But now we can break that down even a little bit more, right? So we can classify our elements in two different ways. We can classify our elements, so we can classify our elements as atomic or molecular. So atomic elements, which is an example here with neon, basically they're a single element. All right, they exist as a single element, a single atom. Okay, now molecular elements exist. They exist, right? In this case, if we look at oxygen, oxygen exists as two atoms together, O2, right? You're not going to see just a single oxygen atom, just floating around. They only exist as O2. And I got this chart down here that's going to help me out here, right? So there are several different, what we call diatomic molecules. So, as I mentioned, oxygen is a diatomic molecule, but hydrogen is a diatomic, nitrogen is a diatomic, fluorine, and really this entire halogen, right, row are diatomic molecules. Okay? And we also have other elements that can exist as polyatomic molecules. So, this is basically, right, where they exist as three or four atoms combined together. A good example of that is like phosphorus, right? Phosphorus actually has four atoms put together. They only exist as P4. Sulfur, selenium, right? These are examples of polyatomic molecules. Everything else can exist as a single atom, as we mentioned with neon here. Now, we go to the other side with compounds, right? We mentioned this before when we talked about the bonds, when we bring those elements together. So compounds, we have two types. We have a molecular compound and an ionic compound. So I mentioned, right, water has covalent bonds. So if you have covalent bonds, you're labeled as a molecular compound. So water is a molecular compound with covalent bonds. Table salt, right? Sodium chloride. Sodium chloride, we mentioned, has ionic bonds, right? Because these are cations. Our anions and our cations, all right? In this case, the chlorine and our cation. And in this case, we're in the sodium. Now, right, what we see here, right, is that ionic compounds have ionic bonds. Okay, and a huge hint with ionic compounds is that it has to be an ion. Okay, if it's not an ion, it's not an ionic compound. That's as simple as it can get. All right.